Let's talk about factoring binomials. So a binomial is two terms added or subtracted, and we're factoring. So often all you can do is check for any common factors and factor those out. But there are special types of binomials that factor in more complicated ways, or that don't factor. So if you have a square plus another square, that does not factor unless there happens to be a common constant factor. They can be factored out, would be all that could be done with that. But a difference of squares, a square minus another square, so a squared minus b squared, that splits up into those two binomial factors of the first thing that's being squared minus the second thing being squared, and the first thing plus the second thing. Sum of cubes and difference of cubes each have their rules as well. So you have to identify what's being cubed in the first and the second term, and plug those into these formulas. You won't need to have memorized. You won't see sum of cubes or difference of cubes on a test. You may see them on homework and quizzes. So have somewhere a note that you know where it is to look up quickly if you need it as you're doing homework and quizzes, and know how to use those rules. But you don't have to have them memorized for this course. So let's look at some examples. Factoring binomials: x squared minus 5x. So the first thing is just see if there's common factors, and there is here. They both have an x. So this is x times x minus 5 times x. We can factor out that x, and it's x times x minus 5. X squared minus 4, so that's x squared minus 2 squared. It's a difference of squares. It's going to be x minus 2 times x plus 2. You can write those in either order, so it could be x plus 2 times x minus 2 also. X squared plus 9, that's a sum of squares, does not factor. We would call that a prime polynomial. 9x squared minus 16. I don't see any common factors, but it is a difference of squares. 9x squared is the square of 3x. 16 is the square of 4. So this is going to be 3x minus 4 times 3x plus 4. All right, then we have 2x cubed minus 8x. Don't just see that cube and immediately think difference of cubes, because 8x isn't a cube, so x by itself isn't a cube, 2 isn't a cube, but what we do have is a factor of 2 in both terms and a factor of x in both terms. So I can factor out a 2x, and what's left in the first term is x squared. So that's 2x times x squared. The second term is 2x times 4. So when we factor out the 2x, we're left with x squared minus 4. That's a difference of squares. 4 is 2 squared. So this becomes then 2x times x minus 2 times x plus 2. X cubed minus 3x squared. That there's an x in both terms, and the lowest is x squared. So we can factor out an x squared from both terms, and we're left with x minus 3, which doesn't factor any further than that. Now we get to x cubed minus 1. That's actually a difference of cubes. X cubed minus 1 cubed. And the difference of cubed rule says that that result is going to be x minus 1 times x squared plus 1 times x, which is x, plus 1 squared, which is 1. And then x cubed plus 8. 8 is 2 cubed. And the sum of cubes says that's going to then be x plus 2 times x squared minus 2 times x plus 2 squared. So one more example then, x to the 4th minus 16. We don't have a special rule for difference of 4th powers. If you think of it as x to the 4th minus 2 to the 4th. But we can think of this as the square of x squared minus the square of 4 then this is going to be x squared minus 4 times x squared plus 4. The x squared plus 4 doesn't factor anymore, but the x squared minus 4 is x minus 2 times x plus 2 times x squared plus 4. So if you want a rule for difference of fourth power, it's always, if we have a to the fourth minus b to the fourth, it's always going to be a plus b times a minus b times a squared plus b squared. But there comes a point where you can just do the difference of squared twice, then that'll get you there. So that's factoring binomials.